Yeah. So any questions about this? Just have any of you had problems with OCaml installation? I've heard one person had troubles with OPAM, but OCaml? Yeah. Yeah. No penalty.
No penalty.
Yeah. Yeah.
Once the automator is set up for the data homeworks, we have infinite resubmissions.
Yes. So we're going to have a division. So there's going to be some of the tests are going to be public. Some of them are not. None of the ones with edge case, all the edge cases ones will be public. So you don't have to worry about getting caught up in some sort of like, oh, you didn't deal with an empty program and now you lost a bunch of points. So the hidden ones are going to be more complete programs, programs that are more realistic, the sort of things that you would want to be compiling. And so they're there just to make sure that you want like hard coding in answers, because that's not solving the problem. Yeah. So you have, if you can do it via OPAM. I can go to the website about this. Yeah. So if OPAM for Windows exists, then you can use that. No? Doesn't exist?
The best thing we can do if you have Windows is download the systems for Linux.
Okay. You can also use CSIL. Yeah. You shouldn't be like, I don't know, DDoSing the autograder, but there's not going to be, I don't think there's going to be a time limit.
You can only submit one submission in an hour.
I don't think we'll be doing that. No, I don't think we will be doing that. No.
Okay.
But again, the fact that there are going to be hidden tests means that it's not smart to, means it won't be smart to just hammer down each error as it shows up. You have to get your code that's actually correct.
You can build a test result for even test cases that feel like it's the homework is due.
You don't know until the homework is due. Yes.
But when you we go to Cecil and just like work with Charlie Cecil then? Like,
Yes.
is the OCaml and Cecil like
It should be sufficient. Yes. I did something, I didn't do it exactly a compiler, but I did something very similar from completely on Cecil. So
like I don't want to spend everyone else's time so we
yeah, sure. Okay, so going, I guess here's the instructions, but that doesn't work on Windows, I guess. So I'm sorry, I'm not experienced with Windows. So there's a distinction between a couple of different things involved with coding OCaml, and also just programming languages in general. We have code files with a specific ending. These can get, you can run them, you can interpret them, or you can compile them to something else. You also have a REPL, which does the interpreter, which is an interpreter for OCaml. It stands for read eval print loop. So you type in, for example, myfun2 of 5, and it reads that in, it figures out what the value is, it finds out that it's 63 with some side effects along the way. It prints out those things, and then it lets you enter more things. That's what a REPL is. They're pretty common. Python also has a nice one. Yeah, so one of the things that the REPL is useful for is if you want to just play around, see what the different values are, how your function works, before writing code that's supposed to do a specific thing. So as you can see here, in order to do that, you're going to need to pull in the functions that you wrote in your files. So for that, you use the use command over here. So you can see here, there's a file with 2 functions in it. When you use it, these functions suddenly become available. You couldn't call them before, now you can. And I do call them there. Any other questions about this? It's just important to make sure you realize that they're not the same thing. The file being compiled and then run is different from typing random pieces of code into the REPL. It's just a different context. So for compiling, you could just say OCaml and then the program name. So this compiles it to a less efficient representation and then just interprets it. So you can do this if it's a small program, you don't care about speed, it's pretty convenient to just do it. You can also use this OCaml opt, which is the compiler for OCaml, and you can compile it into an executable, the program, and then execute it. And then it'll do whatever it said it would do. When you have large projects with lots of files, you need to pull in lots of libraries, you want to be using a dependency manager. So you're going to be using Dune. We're going to set this up for you so you don't have to deal with it, because dependencies and files and stuff are really complicated, and that's not the point of the course. But you should know that there have to be specific tools for using these dependencies. Okay. So here's the first practice thing. So I want everybody to write down, if you have paper, that's great. If you have a computer, that's also good. Write down a type that represents a student. It doesn't have to be any particular representation of it. And then maybe you don't have to write the function to print out the info. If you're on a computer, it's convenient. So that would be great if you could. On paper, it might be kind of tedious. Yeah, but the important thing is write a type and then sort of sketch out what the function would look like. So I think some of this material was covered in last lecture with the box. You have to unpack the box and look at the different tags. So here, I think name and gender and housing location would be tags. Make sense? Yeah. Just define a type that has something like this. It doesn't have to be these in particular. Just pick your own pieces of information about a student. If you can, pick ones that are different from each other. So I had year, could be numbers, or it could be something else. This one's sort of a binary one. So hopefully you'll be using both the conjunction, multiple types, the product types, and also the sum types, where the product types are where you have multiple, where you have both of them. So you could have an int times a string is both an int and a string, or the sum types, which are types where it's an either or. So that's sort of the point. If you know how that works, don't. If you want to look at the lecture notes, that's fine. The point isn't memorizing the syntax. The point is knowing what it represents.
Why are we avoiding?
Yeah, so we want to use options here. So we have a, so we could say, we could use an option. So we could say it could be some of some state, right? Or none if they just came from California. Let me angle this so it actually points. Not sure if that's possible. I'll just put the slides up later. So we could say that this is a option, a string option. Let's go a little further. Let's say we just want to make this. There's two possibilities, but we don't want to use a bool because bools, you can sometimes get them flipped. You can think that it means California when in fact it means not California. Yeah, so we need to define that above. So here we could say type whatever, cal, is equal to cal or no cal. I guess that's kind of confusing. We could give a type like this. And then down here, we could say that this type student is made up of one type cal, which can be either this or that. So this works very similarly to a Boolean in that it has exactly two things it can be, and the casing is basically the same. When this gets compiled in OCaml, it probably gets compiled down into a 0 or 1. Can't say for sure, but yeah, I'm pretty sure. So this is basically how you make types. Yeah?
Don't we need to define what cal and not is?
No, that they are themselves. Not is a value of type cal. I guess we might maybe want to have them not overlap in names, but
No, I meant like, we need to like define what.
no, they're not strings. They're just themselves. They're just themselves. Yeah, they're inherent values. So one thing we could do is we could say, I don't know how this would work for students, but we could say type color is equal to green, red, blue. Got it? So here we can say the green is just green. It's not a string, it's not an int, it's just itself. Okay, so now how do we write a function? Let's say we have, let's say our student is, I'm going to do a gender one. So type gender equals male, female, other of string. Okay. So if I wanted to case on this, what would I do? If I have a function, I don't know exactly what to do here. Let's say just get a character from it, abbreviation of G, which we can say is of type gender. Then how would we write this function? Did you cover this? I think you did. Opening boxes. Oh yeah, let's say we want to return a character. So the way you type that out is this. there's a specific piece of syntax that we want to use here. No? Sorry? Yes, yes, that's right. Great. So we say match G with, and now we give the options. So now we can say this goes to M dot, dot, dot. That's the name of the function. So you could do this. And then what do you do here? This here is not correct. What's wrong with it? This function will not compile. Sorry, can you speak up?
Oh, I'm not sure. So other.
Yeah, other needs, it's not, it needs to be a string, it needs to have a string. So it's an other of a particular string, it's attached to a string. So we could just say it doesn't matter. What?
Other has to have.
So just like Kali is just a value itself, other is a value itself. It just is always attached to a string. There's always a string that goes along with it, whereas there isn't one for Kali. So here you could just, if you did this, it would be correct. Underscore means it can be anything. So whatever the string is can be, you could use it. So you could say that, okay, we're going to take, I forget how to do this in OCaml, so this is wrong, but you could do something like this, where you can take into account what the string is in the type. So if we change this to be, instead of this, let's do a year system. So you can have type year is equal to freshman, sophomore, etc. And then let's say super senior of int, because we don't know how many years they're going on. We don't want to come up with specific names for that. So now if we want to take this, we want to take this year, a value of type year, and turn it into an int that represents what year it is for them. How would we do this? So we define a function. So let get year num of y. I'm actually blanking on whether you have to put a fun there. I'm going to say, okay, you'll figure that out. Here's the important part. So what do we do here? It's basically the same thing as before. But this time we want to actually do something with the values. Maybe can you answer?
I'll just think about this.
So what would that, what would the first step be? So what would you match? Yeah, we match y. Mhm. Yeah, so I'll fill in most of that. So we match y with freshman and sophomore and junior and senior. And well, what do we do here? Yeah, good. Thank you. 1, 2, 3, and 4. And what do we do here? So someone else? I can go around the classroom. Do you have an answer?
Sorry, I'm the
Oh, wait, you're the other TA. I know you. Wow, masks.
And also also,
But-
this is super severe on me. They probably the super severe all professionals.
I'm saying that, so the int is only attached to super senior. So these all don't have attached integers, but super senior could be of any year. I mean, not practically speaking, but we don't know which one it is. So if we want to get a year here, I didn't actually specify what the int represents, so you can just pick something here. But let's say it's X, then what do we want? What integer do we want to return? X, sure. Seems good. So it already has an integer, so we can use the integer that's attached to it already. Does that make sense? Okay, great. Let's go on. Yeah,
For the get years, we have to say why it is of type here.
so they can figure it out. OCaml's, the compiler can infer a lot of the types for you. So sometimes you have to specify it, but normally the reason you specify it is because it helps with debugging, because it makes it clear what specific types the things have to be, and then often things just line up. The code that you're supposed to make, like it compiles and it runs, is basically the hope. And this happens a lot. If you can get the types right, then a lot of the time your program is going to be right too. Here's another example. I guess I should have used this example. But you can see here we have a type not only that can be of nothing and can be of an int, but here we have a type that can be nothing. It can have nothing attached to it, like cube, or it can have an int attached to it, or it can even have another non-basic type also attached to it. So here that's an int option. So you can see a function down here that works with this, where we want to get the volume of something, or I'm not exactly sure what this is. Is it the volume? Looks like it. Volume or area, depending on 2D or 3D. So here, when we match it, we have two options for the rectangle. So we don't have to say rectangle of n and then match on n. You can just have it all inside a single match. Does that make sense? Yeah.
Sure, this underscore. Something like underscore override the data point.
So what the underscore means is it can be anything. So it automatically matches to anything. So if you, yeah.
That underscore could be X, not any.
I'm not sure if it can be replaced with X. I think it's specifically meaning it can be anything.
Oh, that one.
Do you know? You can correct me.
I think you don't need the thing that you're trying to match the thing. So basically, you can match the same.
You want to use the underscore when you're throwing away the information. So that way you don't have the temptation to use the variable that you got. The other reason you use it is, say, if I wanted to have a function that just tells me what the dimension is of a shape, then I don't want to come up with 3 separate cases, one for triangle, 2 for rectangle. I can make it one single case. I can make it the one case of the cube, and then everything else gets mapped to 2. So if you want a single case to cover multiple, that's how you do it. Different languages do this in different ways. But yeah, that's the way OCaml does it. So I was going to maybe talk about I gave some explanations, some examples on here to talk about. So here you can see an option type where the option type can be none or some of something. So does anyone want to explain why safe divide? What's the point of using safe divide here? Hopefully, try not to use the exact words I used above. Yeah, so when we say x divided by y, then that division is not supposed to work when y is 0. That's not part of what division means. So if we return a number, if we return an int, or if we were doing this with floats, we return a float, then that's not correct according to what math should be. So instead, we want to return something that properly reflects that this is not an integer. So we can say when we divide, we either get an integer or we don't get one. Yeah?
What are the keywords?
None means, so an option is, I'm going to go back here. So we can say that an option is either none or it is some of something. So it's just like any other, it's pretty much just like any other of these types that we've done. The only difference here is that it's not with a specific type. So we can say that we can have an int option or we can have a string option, and it doesn't say exactly what it is, but it's otherwise the same. Yeah. Yeah.
So as far as I'm concerned, like none and some are not like keywords of OCaml.
They act like they aren't keywords, but they are there. If you just type in OCaml, pull up the interpreter, none will exist without you having to define it. Because it's really useful.
Oh. Oh, wait, so OCaml already defines this for us.
Yes, I write this out just to show this is basically the same thing as the other types that we were working with.
Are you supposed to have that like
Maybe not, I'm not sure. That's one of those things I change it if the compiler yells at me. This doesn't look as good, but it's probably right. Put it like that. So the reason is because I practiced doing SML, which is very similar, but it has small syntax differences. So I got tripped up on some of these things. Yeah. So yes, that is a good question. It is kind of like null. The thing is that null in languages like Java, anything can be a null. Like absolutely everything can be a null because it's an object, and an object is a pointer sort of, and the pointer can be a null pointer. So what the point of using these option types are is to explicitly, is to be able to rely in some cases that you have an actual value. So you can't always rely on it. So when you do division by 0, when you do, I'm sure there's plenty of other things you can think of, but you can't always rely on it. And for the cases where you can't rely on it, you should produce an option type. And in the cases where you can rely on it, you're totally safe from no pointer exceptions. And that's a great thing to be free of there because they're really difficult to track down. So it's an easy aid to programming, having these option types that have you explicitly say, this is what I know about this value. I know that this value has to be an integer. It cannot be a null integer. Yeah. Good. So this is kind of more complicated, but you do it the same way. When you get something that could be an option type, you want to match on it, where you can say, okay, if this is a none, then maybe I just want to continue on whatever I was doing, ignoring the result. Or maybe I want to change something up about the code that I'm running. because it got a none. So you can explicitly say, if it doesn't work, then here's what I'm going to do. So that's one of the main things. Recursion. So it's better to use recursion than loops when you can. Yeah. Yeah.
So why you see like there's some two, some three, why some two, some three?
Here.
Yeah. Right here.
Yes.
We're trying to like implement a lookup table, right? The three lines, three assertion lines in the code blocks, right?
Not a table. So you can look at what the type signature tells you about what it's doing. So what the type signature here says is you're taking something of any type, and then you're taking a list. And this list is defined not in terms of like, again, like an array list in Java or like an array in C. It's instead defined as basically like a stack. And because stacks are generally, what is it, first on, last off. That's why the 3 ends up being more recent. That's why it makes it more convenient for you to get the 3 first. So that's why we picked that to be the precedence here.
Sum 3
Sum 3 is a value of type int option. And your function, as you can tell, is supposed to produce an option type. All right.
It's not like you know, because option only has some or none.
Yes.
So that's the reason why. And 3 is an option.
3 is an int, but sum 3 is an int option.
Oh, it's an int option.
Yeah.
I noticed that you define like let underscore z. Is that like a definition of a method, or is that a definition of like?
So the reason I do this is it's sort of defining a variable, but then I'm not going to use it. I just immediately throw it away. So I don't bother finding it.
That's like wondering why.
Oh, because I want to do this assert. So what assert does is it checks that this thing is true. And if it's not true, then it crashes. Lookup opt is the function you're supposed to be implementing. So these asserts here are test cases. They're simple test cases, but they're test cases for the function that you're supposed to write. Yeah.
What is the reason behind assigning it to some like dummy variable underscore and not just having the line assert?
I don't know if that's legal, Camel.
Oh, okay.
I don't think you can do that.
On the assignment 1, actually asking us to uncomment the 2 lines and after the finish of the solution.
Okay. Sure. Yeah. It doesn't really matter. I could delete these, I guess, if it's legal. Have to look at it. So, yeah. Any other questions about this stuff up here? I want to talk about recursion. I know you've probably covered it in previous courses. So you get the idea of what recursion is, but I just want to stress it's not necessarily faster to do recursion than to do loops, but it's a lot simpler. You get really short pieces of code when you do recursion. And so personally, I think it's a good habit to get into. Writing your functions recursively. You'll find this very helpful for the stage of the class where you're navigating ASTs, where you have a structure of the program that's tree shaped, and then you want to recursively deal with each part of the tree and combine them back together. So don't think about loops very much. Try to think about recursion. Try to think about piecing your problem into different parts, solving them, and combining them together. Does everyone understand this piece of code? This function, I can make it bigger too. I like how OCaml just has very simple if then else. No brackets, no curly brackets, nothing. Yes. Yeah. So you can use actually single equals. And the equals here is actually, we don't need to get into that. But yeah, you can tell n mod 2 equals 1. This is pretty much pseudocode. That's the cool part about OCaml. Is you have pseudocode that's pretty much what the resulting code is going to be. Yes, you have to do let rec in front of almost all your programs, since most of your programs will be, a lot of your programs at least will be recursive. So let rec is basically the thing that tells you what you're writing is OCaml. If you want to do mutually recursive functions, you have to use and, I think. So you say let rec hailstone, and then you can say and some other function, and then you don't have to use rec. So the and tells the compiler these two functions have to be able to reference each other. Here's pattern matching. We talked about that already. You can see here that you can pattern match not only on things that are explicitly, not just on those enums, essentially, that we were working with before, but also on lists. And lists are a recursive, or I'm not sure if that's the right term, but they're a recursive data type where a list is made out of another list. Yeah?
So I noticed when you talk about the
Yeah.
you like
Yeah. You mean like online?
yeah, or
There should be something.
because I'm curious how
All right, so you can see hailstone. It's interesting. So it goes from int to unit, because the only time it returns something that's not a recursive call is this print string, and print string is a unit. You do a double semicolon to tell the interpreter that you're done. You don't have double semicolon in the code file itself. You do it in the interpreter to say, I don't want to type anymore. I'm done with this function.
So like in our previous like example of like student attribute really going over the math, you don't need double.
No, you don't. You can use single semicolon to say, ignore the first value, or do the first value, but then throw away the result, and instead I'm going to use this next result.
Okay,
So here, if I call hailstone of 5, all of these are going to say 1 reached because, yeah, there we go. But if I do it for something bigger, I don't know how big it has to be before this gets too slow, but if I key smash or whatever, okay, that's too big. Okay, put in an extra semicolon. But you can see it's pretty fast. There we go. It can even do things up to starting from hundreds of thousands. Okay, going back to here, what do you mean?
like within like a file.
In a file, you just say hailstone of something. So the way you apply functions is, again, this is different from most languages where you put where you have the function name, then you have parentheses around the argument. Here, Instead, you just have the function name and then you have the arguments, no parentheses. Or you put parentheses in if you need to bunch up something to say, okay, I want 1 plus 1 to be its own thing, rather than taking 1 as an argument and then plus as an argument, and 1 as an argument again. But outside of that, you just have the function and then its argument, one at a time. Yeah. Unit is a type, which is, here's type unit. Make sense? I mean, it's actually this, but so we've had all these types that can be 2 different things. Now we have a type that can only be 1 thing. So, and that's the same type that all print functions do, resolve to. If you don't want your function to do anything other than like print things and change files or whatever, then it probably is going to have a unit return type, because it's not returning anything. What? I mean, it's an actual value. So whereas void is sort of just saying this, there's no value here. So it's different in that respect. Yes. So this is the function, is the type of Hailstone. Hailstone is a function. In functional programming, functions are values. So we have 1 is a value, 1 has type int. Unit has type unit. And Hailstone, the function, is a function type from int to unit, which tells you that it always takes an int and it always returns a unit.
In this case, we always pre-publish.
Well, there's a mathematical conjecture about that, but the idea is yes. Maybe it runs forever, who knows? So I want to look at, we're getting kind of late, so if people want to leave, yeah, you can. I just want to bring up lists for pattern matching, because pattern matching on lists is one of the most basic ways of doing these recursive functions. And a list, again, it has a base type, sort of like the unit type, which is not in words, it's in characters, it's built in. So this right here is the empty list. And it's basic. And then it can also be, so if we have type list, again, this already exists, but type alpha list is equal to either the empty list, or it's of type alpha and also an alpha list. And so the fact that list is referred to in the definition of list is what makes this a recursive type. Yeah?
So if you set 1 element.
So then if you have a list of only 1 element, then that would be this one right here, where the 1 element is X, and then the list, that is the tail of the list, is what it's called. This is the head of the list, this is the tail of the list, is an empty list. Go back to here. So this is essentially what an alpha list is. Apostrophe A means it can be any type.
No, third one.
Yes,
What
down
is
here.
there now?
Oh, this? Remember what asterisk does? Someone else? It's a product type. It says you have both of them. You multiply them together. You have both a list. You both have a list, and you also have a value itself. This is the head here. This is the tail. I'm just going to double check I didn't miss any important slides, but I think we're done. We'll do patina later, since you don't have to write compiler stuff for that yet. All right, I'll still be here for a bit, but I think we're done now. Thanks for coming.